In this video, we are going to discuss concept through questions from the DBMS topic, integrity constraint and ER model. Okay. From integrity constraint of the DBMS, this is one of the standard model question which given many times in a competitive exams. So the question is, how many super keys possible in the relational schema are with n attributes a1, a2, a3 up to so on an and some candidate key. Here there are two candidate keys is given. A1 is one candidate key and A2, A3 is other candidate key. If A1 one candidate key, A2, A3 is the second candidate key, then we need to find how many total number of super keys for this relational schema with n attributes. Okay. So before discussion of this question, we need to discuss about candidate key and we need to discuss about super key. So let us see in detail discussion of candidate key and in detail discussion of super key. Okay. So then we come back to this question and we solve this question, and we also solve few more other similar model questions of the finding super keys. Okay. So the discussion, the concept which we are discussing related to candidate key and super key, not only for this question, and that concept is applicable for so many questions in competitive exams. Okay. So it is one basic thing and important thing and very frequent questions in competitive exams. So listen careful, friends. Okay. So let us see the definition of candidate key. So listen carefully, candidate key is minimal set of attributes which can differentiate the records of relational schema uniquely. So there are two important things. One, it should be minimal attribute set, and second, records of the relational schema should differentiate by these attribute set uniquely. So all the records should differentiate the by using this minimal set of attributes. Okay. So there are two important things. Let me write the definition. So many theory based questions related to the definitions also. So listen carefully. So candidate key is minimal set of attributes which can differentiate records of relational schema uniquely. Okay. So two important things we need to observe in this definition. So candidate key is minimal set of attributes, and those attributes can differentiate the records uniquely. So for example, if we take some employee database, with fields employee ID, employee name, date of birth. Okay, so it's as like a general data, so very known kind of database table. So EID is unique for all the employees. Many employees can have same name and same date of birth. Okay, so no two records with the same EID. To maintain that constraint, okay, so we should assign EID as candidate key of this relation. Candidate key is employee ID. Okay. So EID is minimal attribute set which differentiate the records uniquely. Okay. If EID itself differentiating the records uniquely, okay, EID combines with ename also differentiate the records uniquely. EID combines with date of birth also differentiate the records uniquely. EID combines with ename date of birth also differentiate the records uniquely. Okay. By chance, if I take attributes EID along with ename combination, these two attributes also guaranteed differentiate the records uniquely. These two attributes also guaranteed differentiate the records uniquely. But this is not minimal attribute set. Okay, because not only EID combines with ename can differentiate the records, removal of ename, only EID also can differentiate the records. Such a attribute set is not candidate key. So it is a failure of the definition. It is not candidate key. Okay, so the reason is it is not minimal attribute set. So it doesn't mean that candidate key should be only a single attribute. So two or more attributes also can form candidate key. Let us take one more example. So the database table name works for. Okay, works for. So employee ID, project ID, okay, one more field since. So it means to say employee working for project since some date. It's a date attribute. So assume that constraints of this database table, assume that employee can works for many project can works by many employees. So it means to say employee E1 working for P1, assume since 2015, employee E1 also working for P2 since 2018. Okay, similarly, same project P2 works by the other employee E2, okay, let's say since 2015, like this. So in this case, we can't take employee ID as a candidate key because employee ID not unique for all the records. We can't take PID as a candidate key, project ID as a candidate key also fail to assign here because project ID values are not unique for all the records. So here the possibility of candidate key, here the possibility of candidate key is combination of EID and PID. So two attributes combinedly forms the key. Here one single attribute is forms a candidate key. So generally we represent candidate key field of the relational schema with underline. So for this first example, only one attribute EID is a candidate key. for the second example, EID, PID combinedly candidate key. So if only single attribute forms the key and such a candidate key is called simple candidate key. Simple candidate key. Simple candidate key means candidate key with only one attribute. If only one single attribute forms the candidate key for the relational schema, then such a key is called simple candidate key. If two or more attributes combinedly forms the candidate key, like this second example, two or more attributes combinedly forms the candidate key, such a candidate key is called compound candidate key. So compound candidate key means candidate key with two or more attributes. So simple candidate key means candidate key with only one attribute. So compound candidate key is candidate key with two or more attributes. Candidate key with two or more attributes. If two or more attribute forms the candidate key, such a candidate key is called compound candidate key. So a relation can have all simple candidate keys, a relation can have compound candidate keys. In a same relational schema can have some simple candidate keys as well as compound candidate keys. Okay. So this is the definition of candidate key, and even though the primary key, alternative key concept is not given in above problem, but just for idea. So let us see difference between primary key and alternative key. Primary key, alternative keys. Primary key is any one candidate key of relational schema which always no null values. So null is unknown or undefined value. So any one candidate key and which is always not null. Values of the attribute is always not null values. So alternative keys are all candidate keys of relational schema. all candidate keys of relational schema except primary key. Okay, so obviously primary key is at most one for any relational schema, at most one primary key is allowed for any relational schema. So many alternative keys allowed, many alternative keys, 0 or more, many alternative keys allowed for relational schema. So whereas primary key not allowed null values, and whereas alternative keys allowed nulls. Okay, so common thing, similarity between primary key and alternative key, both are candidate keys. Primary key is also one of the candidate key and alternative key is also candidate keys except the candidate key which we used for primary key. So like for example, I am just using some general example. In this relational schema, let's say these are all attributes A, B, C, D, E. Okay, so assume A one candidate key, B one candidate key, C, D combinedly one candidate key, total 3 candidate keys. Assume that A can differentiate the records uniquely, B can differentiate the records uniquely, combination of C, D can differentiate the records uniquely. So assume these are the candidate keys. So as we discussed before, one of the candidate key can be assigned as primary key. Assume if A is assigned as primary key, okay, then remaining all candidate keys, okay, remaining all candidate keys except the primary key is become alternative keys. Got it? So these all are become alternative keys. Alternative keys, where this primary key field not allowed null, alternative key fields are allowed null. Means we will be inserting data for every record. A is one candidate key, B is one candidate key, combination of C, D is one candidate key. So we will be inserting data every record. There must be a value and nulls are not allowed here. So unique and no nulls. Okay, so B and C, D are alternative keys. Okay, so it is non-null values are unique, but it can have null values. So if B null 6, B value is null 8. So like this allowed. Same as the case for C, D, and E can be anything. E is not forms, not belongs to any candidate key. So primary key is one of the candidate key whose field values is always not null. Alternative key is also one of the candidate key but whose field values is allowed the null values. So this is about the primary key, alternative key, candidate key concept. Okay. So what the things which we discussed, we define candidate key, minimal attributes and can differentiate the records uniquely. Okay. So if one attribute forms a candidate key, it's a simple candidate key. If two or more attribute forms the candidate key, it is a compound key, and relation can have simple candidate key and compound candidate key as well as some simple candidate keys and some compound candidate keys also. And primary key and alternative key, any one candidate key whose field values is always not null, so is primary key. All candidate keys of the relational schema except the primary key is alternative keys. So for any relational schema, at most one primary key is allowed, but alternative keys can be many. So this is about the candidate key definition. And next thing to solve our problem is super key. Super key is set of attributes which should differentiate the records uniquely, but that attribute set may be minimal attribute set or may not minimal attribute set. So here the difference between super key and candidate key. So if we come back to the definition of candidate key, so minimal attribute set which differentiate the records uniquely is a candidate key. So whereas in super key, this constraint of minimal attribute set is not required. So only attribute set which differentiate the records uniquely is called super key. Okay, super key is attribute set which can differentiate records uniquely. Okay, that attribute set which we use it to differentiate records uniquely may be minimal attribute set or may not be a minimal attribute set. So for example, if we take the same example which we use it for candidate key, so employee database, employee ID, employee name, date of birth. So we know employee ID is candidate key, no two records with the same employee ID. So employee ID is candidate key. Okay. So super keys of this relation. So if EID unique for all the records, assume some random e-names, so some date of birth. If EID itself is unique for all the records, EID combines with e-name also unique for all the records, EID combines with date of birth also unique for all the records, EID combines with e-name, date of birth also unique for all the records. So the super keys of the relational schema. Super keys. EID one super key which also candidate key, EID ename is a one more super key. EID date of birth is one more super key. EID ename date of birth is one more super key. So like this, EID can differentiate the records. EID combines with ename can differentiate the records uniquely. EID combines with date of birth can differentiate the records uniquely. EID ename date of birth also can differentiate the records uniquely. So these are the super keys. So the difference between candidate key and super key, candidate key is minimal attributes which should differentiate the records uniquely, whereas super key, it may minimal or may not minimal, but all the records of relation should differentiate the record uniquely. Okay, so got it? So are you cleared the difference between super key and candidate key and the difference between primary key and alternative key? Okay, so not only for exam point of view, in interviews also, so software interviews also, these things are very important. So just these are the basic concept of candidate key, alternative key, primary key as well as super key. So super key which forms with minimal attribute set, minimal attribute set super key. Okay, so out of these 4 super keys, EID is the minimal super key. Super key which forms with minimal attribute set is sorry, so is also candidate key. Okay, so it means to say we can define candidate key like this. Candidate key is minimal super key. Okay, so every candidate key is also part of super key, but not all super keys are becomes a candidate key. So in this example, EID not only a super key, it's also a candidate key, but remaining 3 super keys are not a candidate keys. So we can say expressive power set, we can draw like this as per set theory. So assume these are set of candidate keys of relational schema R. Okay, we can say these are set of super keys of relational schema R. So every candidate key of the relational schema is also super key, but every super key of the relational schema may not be a candidate key. So this is the basic fundamental concept for the candidate key, primary key, alternative key as well as super key. Now, as we discussed definitions of these super key, alternative key, candidate key, now let's come back to the problem. Let's come back to this problem. Let us discuss. Okay, let's come back to this problem by using the concept of super key as well as candidate key. So here the question is, how many super keys possible in the relational schema R with n attributes? Okay, I think it is properly visible. Okay, how many super keys possible in the relational schema R with n attributes? A1, A2, A3 up to so on An, and candidate keys A1 as well as second candidate key A2, A3. Okay, so we just before we discussed, super key is one complete candidate key should exist. One complete candidate key combines with 0 or more other attributes. 0 or more other attributes. So super key is candidate key along with, combines with 0 or more other attributes is the super key. So got it? So if we want to say attribute set is super key, in that attribute set there must be candidate key and 0 or more other attribute also can combine, because super key doesn't require minimal attribute constraint, minimal attribute set constraint. Okay. So this problem can solve in two ways. Okay, one way by using set theory Venn diagram. Okay, so first find total possible super keys because of candidate key A1, and find total possible super keys because of second candidate key A2, A3. Okay, so assume these are set of super keys because of candidate key A1. Okay, see, A1 combines with any subset of other attributes. Any subset of other attributes. Which are A2, A3 up to so on An are the super keys. Okay, so clear this. So set of super keys because of candidate key A1. A1 combines with any subset of remaining attributes. Means A1, only A1 is one super key. A1 combines with A2 super key. A1 combines with A3 super key. A1 combines with up to so on An super key, or A1 combines with 2 attributes, A2, A3 is also super key, and so on. So the total possible subsets for this n minus 1 attributes are 2 power n minus 1. Okay, so this 2 power n minus 1 subsets of attributes for the attributes A2 to An. So this, any of this subset, if we combine with the candidate key, where A1 is a candidate key, A1 is must. Okay, any of the subset, if we combine with A1, and that attribute set is super key. So the total possible super keys because of candidate key A1 is 2 power n minus 1. And total possible super keys of the relational schema because of A2, A3, second candidate key. total possible super keys because of second candidate key. Okay, so again same concept. So A2 A3 is must. A2 A3 is must because it is super candidate key. A2 A3 combines with any subset of remaining attributes. So that is A1, A4, A5 up to so on AN is also forms the super key. So A2 A3 combines with any subset of this remaining attribute is forms the super key. So clear this. Again same thing, whatever we done for the first candidate key, same thing we are repeating for second candidate key. So total these are n minus 2 attributes. For this n minus 2 attributes, the number of possible subsets are 2 power n minus 2. Any of the subset of A2, A1, A4, A5 up to so on AN, any of the subset of these attributes if combines with the candidate key and that attribute set is also super key. Okay, so the super keys because of first candidate key 2 power n minus 1 and super keys because of second candidate key 2 power n minus 2. But in this there are many repeated super keys. For example, if I take A1, A2, A3, this is one of the super key which belongs to the first set. It is also one of the super key which belongs to the second set. Similarly, A1, A2, A3, A4. Okay, it is also because A1 first candidate key also includes and second candidate key also includes. This is one of the super key belongs to the first set and also one of the super key belongs to the second set. So these super keys are counted twice. These are counted in first set and counted in second set. So to get the all super keys, we should exclude these super keys which are common between them. Okay, so these are super keys which are forms key attributes A1, A2, A3 must, okay, whereas first and second candidate key attributes combines with any subset of remaining attributes. Any subset of, okay, remaining attributes which are A4, A5 up to so on AN. Okay. So here the total possible super keys, okay, for this A1, A2, A3 as common. So remaining attributes A4 to AN any subset. So this total n minus 3 attributes, so 2 power n minus 3 subsets. So any of the subset combines with A1, A2, A3 which also super key and that super key is intersection to the both sets. Okay. So the total number of super keys, so like in set theory we use it to do like this, first set and second set. So the number of elements of X union Y, number of elements of X union Y is number of elements of first set plus number of elements of second set. So number of elements of X union Y is number of elements of first set plus number of elements of second set minus intersection of both the sets. Okay. So the number of elements count, number of elements of X union Y is number of elements of first set plus number of elements of second set minus number of elements of intersection part X intersection Y. Okay, so is the total super keys. So number of super keys of first set 2 power n minus 1 and number of super keys of second set 2 power n minus 2 and common super keys 2 power n minus 3. Okay, we can simplify further. So if I take 2 power n minus 3 common, okay, so 2 square plus 2 minus 1. Okay, so 4 plus 2 6 minus 1 5. So total super keys of this relational schema 5 times 2 power n minus 3. This is the super keys, total possible super keys in the relational schema if candidate key A1 as well as A2, A3 is a second candidate key. This is one way to handle this problem by using set theory. Okay, so second way, second method, total number of super keys, total number of super keys in relational schema R equal to number of super keys among prime attributes, among prime attributes. Okay, multiplied with 2 power number of non-prime attributes, non-prime attributes. So like this also we can find. So number of super keys of the relational schema equal to number of super keys among prime attributes of the relation multiplied with 2 power number of non-prime attributes of the relation. So let us see the meaning of prime and non-prime. So attribute which belongs to a candidate key is a prime attribute. So in this relational schema, A is one candidate key, B one candidate key and CD is one candidate key. 3 candidate keys. Okay. So A prime attribute, B prime attribute, C prime attribute and D prime attribute. Attribute which belongs to a candidate key, attribute which belongs to one of the candidate key is a prime attribute. That may be a primary or alternative. So prime attribute and non-prime attribute not related to primary key or alternative key. So it's just related to a candidate key or non-key. Okay. So attribute which belongs to any one candidate key is called prime. Clear this? Attribute which belongs to any one candidate key is called prime attribute. So A is one of the candidate key attribute, A is prime. B is one of the candidate key attribute, for this example B is prime. C and D also prime attributes because C also belongs to candidate key and D also belongs to candidate key. If you observe, E is an attribute which not related to any candidate key. E not related to any candidate key of this relational schema. Such a attribute is called non-prime attribute. So in this example, out of 5 attributes of the relational schema, these 4 are prime attributes and this is non-prime attribute. If we come back to our problem, so this above problem, so here n attributes are there, total n attributes are there. Out of that, A1 is one attribute which is candidate key, A2, A3 is two attribute which forms second candidate key, total two candidate keys. So the A1 is candidate key attribute which is prime, A2 one of the prime, A3 is one of the prime. That means here A1 prime, A2 prime, A3 prime, A4 to AN which are not belongs to any candidate key in this question, which are non-prime attributes. Okay. So let me write the candidate keys here, candidate keys of the above problem. Candidate keys, okay, which are A1 is one candidate key and A2, A3 is one candidate key. So overall A1 prime, A2 prime, A3 prime. Okay. So first candidate key one attribute only and second candidate key two attributes. Okay. So now come back to this method. Number of super keys, listen carefully. Number of super keys of the relational schema is number of super keys among prime attributes multiplied with 2 power number of non-prime attributes. So here 3 attributes are prime, n minus 3 attributes are non-prime. Okay. So what are super keys among this prime? Let us see what are possibility of super keys among this prime. So only A1 is candidate key. So A1 itself not only a candidate key, it is also super key. Okay. So A1 combines with A2, also super key. A1 combines with A3, also super key. Okay, A1 combines with A2, A3, also super key. So A1 super key, A1 combines with A2 super key because A1 itself differentiate records uniquely. A1 combines with A3 also super key because A1 itself differentiate the records uniquely. Same as the case next. And A2, A3 is one more super key. A2, A3 is one more super key. A2, A3 combines with A1 is one super key, but already counted it. Okay. So in this example, okay, can we say A2 is super key? Can we say A2 is super key? No. The reason is, okay, only A2 not differentiate the records uniquely. A2 is one part of the candidate key. So the super key means, as we discussed earlier, so super key is such a way that okay, yeah, see, super key, it should have one complete candidate key with 0 or more other attributes. Okay, one complete candidate key with 0 or more other attributes. Okay, A2 is prime but not super key because it's not a complete candidate key. A3 is prime but not super key. A2, A3 is super key because A2, A3 is also one of the candidate key. So super key means it should have a complete candidate key. So A1 is one super key. A1 combines with A2 one super key because A1 is candidate key. A1 combines with A3 one super key because A1 is candidate key. A1 combines with A2, A3 is one super key because A1 is one candidate key and A2, A3 is also one candidate key. So A2, A3 combinedly one super key, it's because it's also one of the candidate key. But only A2 is not super key and only A3 is not super key. So number of super keys among prime attributes 1, 2, 3, 4, 5. 5 super keys possible among prime attributes. Among prime attributes, total 5 super keys. Okay, clear this? So multiply with 2 power number of non-prime attributes. So if out of n attributes, if 3 are the prime attributes, out of A1, A2, A3 up to so on n attributes, if 3 are prime attributes, remaining n minus 3 are non-prime attributes. Okay. So number of non-prime attributes are n minus 3. So the total super keys, okay, total super keys of this relational schema, 5 super keys among the primes multiplied with 2 power n minus 3 is the total number of super keys. Okay, so we can go for set theory and we can go like this. So here in the second method, it is more important that you should able to find number of super keys among the prime attributes properly. Okay, here there is a possibility of mistake here. Okay, so listen carefully. Only A1 is super key because only A1 itself is a candidate key, but only A2 is not super key because only A2 is not a candidate key. It's a proper subset of candidate key. Proper subset of candidate key fields never be a super key. Okay, proper subset of candidate key attribute set. Okay, A2, A3 combinedly candidate key. Proper subset of this candidate key is A2, which is not candidate key, and proper subset of this candidate key A3, which is also not candidate key as well as super key. Okay, so this is the way we find number of super keys